Alright friends, welcome back. In this video I'd like to go ahead and take a look at the next section of Chapter 1, which is Section 1.4, which will take 2 videos to go ahead and discuss here, and that is going to discuss how you go ahead and solve quadratic equations, okay? So real quick about what a quadratic equation is here to start is it's any equation of this form. And what makes it quadratic is the addition of this term out in the very front, where you have some sort of x squared term. Okay, I want you to realize that the reason that we wrote this note over here off to the side, the fact that a cannot be equal to 0, is the fact that if it was, then we wouldn't even have a quadratic, and we would lose this characteristic term that makes it a quadratic. If we lost that, then what you see there is that just is something that looks more like a linear equation, and that's something that we've already taken some time and discussed how to solve. So we need that a to not be equal to 0 for us to even have a quadratic equation here, and it turns out that there are a lot of different methods that you can use to solve quadratic equations. In this video, we're specifically going to talk about 2 methods. One of them is going to be the method of factoring to solve, and the other is going to be this method of extracting square roots, which only applies for a special case or a special situation, and we're going to discuss that as we get to it a little bit later on in the video. So what this, of course, means here in the case of the method of factoring is that we need to remember how to factor, and so remember that that was something that we used to cover back in Chapter P. I believe that was Section P.4. We took 2 days for that, so you might want to go ahead and look up those videos if you need a quick refresher on how to factor, but we're going to go ahead and assume in this video that you know how to factor and that that's something that you're able to do. And we're just going to go ahead and review the process here, right? So a little bit of a step-by-step process here in order to go ahead and solve by factoring, okay? The very first thing that you need to go ahead and do whenever you solve by factoring is you need to bring everything to one side, leaving 0 on the other side, okay? So getting this equals 0 here, that's so important that throughout the video, you're going to see me box this, okay? And that's just so that we can keep track of where my equals 0 is in the equation, okay? So if it isn't already done for us, that's something that we're always going to have to do first. After we get 0 on its own on one side, we're going to go ahead and begin to factor everything that occurs on the other side, okay? So remember how to factor. That would be something that I believe we had a factoring checklist back in the day when we talked about Chapter P. That would be one of those things where we just want to kind of continuously go through, look for a GCF first, and then count the number of terms. Depending on the number of terms, that the factoring checklist said that we factor in a different way, and we're going to kind of go through that as we go through the video here. So those steps 2 and 3 there basically just say to factor whatever you're given. And then finally, as a step 4, what we're going to apply is something called the zero product property, okay, which I'm just going to go ahead and refer to as the ZPP for short. And what that is basically the following, right? If it's this idea that if you were to take 2 numbers and multiply them and then get equals 0, which is why we have that equals 0 in the first step, if you multiply 2 numbers and it equals 0, then that means something specific about your 2 numbers that you're multiplying together. It means that either this first number was 0 itself, or maybe the second number was 0 itself, or maybe both numbers are 0, in which case we're going to have to entertain the possibility of both of those mystery numbers being 0. And that's going to come into play later, so we'll demonstrate that here in a little bit when we get to this first example. So part A, we have this quadratic equation here. We have 2x squared plus 9x plus 7, and that is equal to 3, okay? So again, just to kind of go through the steps, the first step would always be to get 0 by itself on one side of the equation, and we could do that very simply by subtracting 3 from both sides, in which case we're going to end up with 2x squared plus 9x plus 4, 7 minus 3, that is equal to 0. And now that we have our equals 0, again, I just like to kind of keep track of where my equals 0 is throughout the problem, so you typically will find that I like to box that. That's not absolutely necessary, but I do think that makes it a little bit more clear what it is we're actually trying to do, okay? Now, what we're now going to try to do is continue with our factoring step, which would mean that we're going to take a look at everything on the left-hand side that occurs, and we are now going to factor this as a trinomial because it has 3 terms. First thing to look out for is a GCF. I don't believe we have one here because we have coefficients of 2 and 9 with a constant of 4. These are not numbers that have a constant factor, and so this is a trinomial, so we would go ahead and see if this would be something that we can apply one of our special factoring formulas to, like a perfect square trinomial. I'll give away the punchline here. That's not going to be the case. So what we're going to have to do is unfoil this using our guess and check method, okay? You guys can also feel free to use that algebraic method for factoring a trinomial. I have a video covering that as well. Again, check around the P.4 area of the video playlist, and you'll be able to find it there, okay? But I'm just going to go ahead and guess and check here. So if I factor this, I believe some combination of 2x and x will work as the first terms there. As the last terms, we could go with 2 and 2, but when we try to check that, it turns out to not give us the 9x in the middle. So we're going to go ahead and come up with a different way to break up a 4, which is going to be 1 and 4, and this will actually turn out to work here very nicely for us. Okay, so factoring that trinomial 2x squared plus 9x plus 4, that factors into the binomials 2x plus 1 and x plus 4. And now here is where the zero product property kicks in from before. We said that either the first number is 0 or the second number is 0, or maybe both numbers are 0. So how does that come into play here? Well, we have our two factors, right? We have this first factor times the second factor, and it equals 0. And of course, what that means is we don't know really the true value of either one of these, so we have to entertain the possibility by zero product property that both of these could be equal to 0, which I'll do over here on the right. We're just going to basically individually set these equal to 0 and then solve them. So 2x plus 1 equals 0, in which case if you solve that, you're going to get x is equal to negative 1/2, and then the other factor equals 0. So x plus 4 equals 0, solve that, you would get x is equal to negative 4, and these would represent your two answers for this equation, okay? These are two solutions that you can very, very easily check by going to the calculator and doing that whole process of storing the numbers into x, typing in the left-hand side, and seeing that you really do get equals 3 in the calculator. That would be a really easy way to check, very quick way to check, and that would be something that I would expect you guys to be able to do as you move forward here, okay? Just kind of plugging our way through here, taking a look at this next example. It looks like we already have our equals 0, so that's pretty good. So we're now going to go ahead and skip straight to the factorization step. And the first thing we always need to be on the lookout for here is a GCF, and I think this is an example that definitely has one. So I'm going to go ahead and convert this equation to now saying 3x times the leftovers is going to equal 0, okay? And so, what do the leftovers look like after factoring out a GCF of 3x on the left-hand side? That's going to look like 2x minus 1. Okay, and now here is where zero product property is going to kick in for us, because again, we have two numbers that we don't quite know the value of being multiplied together, and it equals 0. So that means that one of these two values is going to have to be 0 itself. So maybe it's 3x is equal to 0, in which case playing the role of x would just simply be 0. That's our first solution. Or maybe it's 2x minus 1 that's equaling 0, in which case x would simply equal 1/2 as our solution, okay? And so we end up with two solutions here, again, very easily checkable in the calculator. I'm going to go ahead and skip part C because it's identical to what we've been talking about, but take a look at part D for a sec, right? So this is one where you're going to have to do a little bit of preliminary work before you can start to do this process that we discussed earlier, right? So some preliminary work means that we're going to have to go ahead and do some work before we can get there. So that work is going to entail distributing in that 4x. It's going to give us 16x squared plus 12x plus 5 is equal to 12x plus 30, okay? And now we're going to go ahead and continue to collect all of our terms to one side, leaving 0 on the other side by itself. And so we can go ahead and get our x terms together by simply subtracting 12x from both sides, but what I want you to realize here is that when we do that, we actually have some terms that are going to fall away and make 0. So 12x minus 12x on both sides of this equation, these are going to cancel out for us. And we're going to be ending up here with 16x squared plus 5 is equal to 30. And we're trying to get that equal 0, remember, so we're going to go ahead and take our 30 and bring that over. So subtracting 30 from both sides, I'm going to go ahead and continue over here off to the side. It's going to give us 16x squared minus 25 is equal to 0. And we do have our equals 0 now, so I'm going to go ahead and get that in a box just to kind of keep track of it. And now we are forced with the task of factoring what we have here on the left-hand side. So looking for a GCF, I don't believe we have one. So we're going to count the number of terms. It looks like there's 2. There's the 16x squared, that's our first term, and then there's the 25, that's our next term. And so we're going to go and try to see if we can factor this using one of those special factoring formulas like the difference of two squares, the sum of two cubes, or the difference of two cubes. And the reason that this is a difference of two squares is because I see a bunch of flags that tell me that that's the case. I see numbers like 16 and 25. These are perfect square numbers. I'm seeing this exponent of 2 right here. That is a dead giveaway. I see we have a minus sign. That's a difference, right? So these are all flags that this is going to be a difference of two squares. We can go ahead and factor that into your u plus v times u minus v, remember. Okay, so we have something that looks an awful lot like u squared minus v squared. So we know how that factors. That factors into u plus v times u minus v. Okay, so let's actually apply that. Playing the rule of u, I believe, is simply going to be 4x, because sitting in u squared seat is 16x squared, so 4x and 4x, and then plus, and then minus, and then playing the role of v, since v squared is sitting in 25 seats, the square root of 25, of course, is going to be 5 here for us. So 4x plus 5, 4x minus 5, that's going to be the factorization that we want. And now that we've factored this thing, it doesn't continue to factor. We're going to go ahead and kick in with zero product property signifying that we are multiplying two numbers. We don't know the value of either of them, but we know that they multiply to make 0. So we're going to set both of these individually equal to 0 and solve. So 4x plus 5 is equal to 0. If you were to solve that up, you would get x is equal to negative 5 over 4. And then if you were to set 4x minus 5 equal to 0 and solve that, you would be getting x is equal to positive 5 over 4. Okay? And so those would be our two solutions for this quadratic equation here. So again, very easily checkable in the calculator, and that's something that I would expect you guys to be able to do. Okay, and again, I said before that we do have that expectation that you guys do know how to factor as we go throughout the video here. So again, P.4, days 1 and 2 videos. If you need to go back and review your factoring skills, make sure to do that. I'm going to go ahead and skip out on examples C, E, and F here just because it would be more of the same in different various methods for factoring. But I'm going to go ahead and skip to this next method here, which is going to be this method of extracting square roots. And this is going to be a method that does work, but only for certain situations, okay? So this is actually somewhat of a special case, which I actually like to go ahead and write off here off to the side. So the special case that this applies to is when you have a quadratic equation where x only shows up in one spot, okay? We couldn't do that for an example like part E up here because how many times does x show up? My goodness, it shows up 1, 2, 3, 4. It shows up in 4 different terms. But for extracting square roots, you have the green light to apply that method if you have an example where x only shows up in one term, okay? So only once there in example A and only once here in example B, okay? So whenever x only shows up once, that's when you have the green light to actually perform this method. So let's actually go through and do this method, right? So what does it say up here? It says get the squared term on a side alone and then square root both sides, okay? I'm actually going to add something to that because this is something that typically students tend to forget. You are going to apply a square root of both sides, but it's going to be a plus or minus square root of both sides, okay? Remember, when you're doing a pure algebra problem and you're taking a square root to undo an exponent of 2, you always, always, always need to include plus or minus to consider the idea of, you have a negative factor instead of just strictly positive factors here as well, okay? So we're going to get the x squared term by itself, and we could do that simply by taking both sides and dividing by 4. And so that's going to give us x squared is equal to 12 divided by 4, which makes positive 3. And then we're going to undo that exponent of 2, of course, by applying a plus or minus the square root of both sides. If you forget the plus or minus, then you're going to be missing out on one of the solutions that you're going to end up having here. So x is going to be equal to plus or minus the square root of 3, and that does represent our solution. Yes, that is it. But don't forget that this really does represent two solutions for the price of one, okay? Because of that plus or minus, we have x equaling the positive square root of 3 and x equaling the negative square root of 3, okay? So when you write that plus or minus, you really are emphasizing that you have two solutions. And if you forgot that plus or minus, you would only be writing one of those two solutions, which means that on a quiz or a test situation, you would have to unfortunately get points taken off, okay? On this next one here, we only have x showing up in one place, so that means that we can isolate it. So we're going to go ahead and apply this extracting of square roots here. So I'm going to go ahead and do a plus or minus square root on both sides of the equation, okay? And that is going to undo that exponent of 2 on the left-hand side, okay? Now, that's going to leave us on the left-hand side with x minus 3, and that is equal to plus or minus the square root of 7. Do we need those parentheses any longer? Well, there's no negative in front of that those set of parentheses, so we can just feel free to drop them, in which case we could just go through and undo that minus 3 by simply adding 3. Now, conventionally speaking, and what that means is that this is just something that mathematicians have widely agreed to do in general, is when we write answers like this, what we're going to try to avoid is writing our answer as plus or minus the square root of 7 plus 3 in that order, okay? And the reason for that is because of handwriting, right? If your handwriting is worse than mine and you accidentally wrote this result and your square root looks like it covers that plus 3, that would technically not be a correct answer because in that case, we would simply get plus or minus the square root of 10 because that's 7 plus 3. And that's not what our result was. In this context, what we would typically try to do is minimize confusion by taking that positive 3 and writing that first. So positive 3, I'll just write there because we added the 3, and then plus or minus the square root of 7. And then that's going to represent our result there, okay? So conventionally speaking, we typically like to try to write integers first before square root numbers. And again, don't forget that this is two solutions for the price of one with the minus and one with the plus. So x is equal to 3 plus the square root of 7, and x is equal to 3 minus the square root of 7. So 2 different answers for the price of 1 there. So extracting square roots is a very, very easy method to use, but again, it only applies when x shows up in exactly one term. If x shows up in more than one term, then we might have to use one of these other methods for solving, like factoring, or maybe some of the methods from the next video here. But that's going to do it for this video here. Thank you very much for your attention. If you guys have any questions at all, as always, feel free to get those answered in class by asking or send me a quick message. Thank you very much for your attention, and I'll speak to you in the next one.